In today's lesson, we are going to be looking at depreciation. So this is another one of the concepts that we're going to be looking at in our financial part of the course. And we've already looked at kind of the opposite of depreciation, which was appreciation. And again, remember, appreciation was when the value of assets or items increases over time. So if you think that depreciation is the opposite, you probably already have an idea of what it is. Or what it refers to. So what we're going to look at today is just look at certain financial situations that do show depreciation, as well as how we can calculate it. It is going to be very similar to appreciation, just again, some of the terms may be different because we're dealing with a slightly different concept. Just as a warm-up to get us thinking, we have 4 different graphs here or relationships. We want to think about or state a reason why each one doesn't belong. So there is something that you might be able to come up with which for each one for a reason for why it doesn't belong. Right? So take a second to think about it. You can pause the video if you want. And if you can't really think about it, that's okay as well. But just to kind of get you thinking and ready for the lesson. If we're looking at the first one up here in the top left, why does this one not belong? Well, you could say it's the only one that's increasing at a non-constant rate, right? We see that or the only one that's that's an increasing non-constant rate, right? So we can see that the second graph is decreasing, the third one is increasing, but it's increasing at a constant rate, and the fourth one is decreasing at a constant rate. So it's the only upward curving graph or relationship. You could use that idea for the second one over here. Why doesn't this one belong? One thing you may come up with, maybe because it's the only decreasing graph that is non-linear, right? Or it's decreasing at a rate that is not consistent. Right? It starts off decreasing very, very fast and then slows down, similar to the curved lines that we've kind of looked at in our distance time graphs. The third one down here, well, you could say it's the only increasing linear graph, right? It's going upwards. It's a straight line, so it's a constant line or a constant change. And the fourth one, or the last one, you could say it's the only constant decreasing graph. You can see that the dots do form a straight line, so it is decreasing, and it is constant. You could also say maybe it's the only graph that isn't represented by a straight line, so it's only represented by specific points. That's another thing you could come up with as well. Again, you may have found something else which is interesting or different for each one, which is fine as well. So if we want to discuss how are the two left graphs similar and how are the two right graphs similar, so again, with that in mind, going back, how are these two similar and how are these two similar? Well, as part of what maybe made them not belong to the group, or what made them different, is that maybe, or we should see that the first two over here, these two are both increasing and the two on the right are both decreasing. So that's what kind of makes them similar. So we can say both increasing and both decreasing. So that's what makes those two similar. So moving on to our actual lesson, again, I mentioned at the beginning that depreciation is the opposite of appreciation. So again, it's the opposite of what we've looked at in the past. Appreciation, we said, was we expect these values or these items, we called them assets, to gain value over time, right? So stocks, bond, real estate, metals, jewelry, art. We talked about some old cars, like the collectibles. Again, certain things like that we've talked about. Depreciation is we expect items to lose value over time. So again, it's the opposite. Instead of gaining value, we expect it to lose value. So this might be more like items such as vehicles. A little bit different from the classic or kind of the collectible vehicles that we talked about in appreciation. If you look at your common vehicles today that you buy at, say, a regular dealership, right? Your Hondas, your Fords, your GMC, Dodge, things like that. Those vehicles lose value over time. If you want to buy a used car, you're not going to be spending more than what it would be brand new. Again, there is the difference for collectible cars, but your regular vehicles do lose value over time. Furniture. Furniture, again, tends to lose value over time. Again, vintage furniture might gain value, but in general, if you have a bed set, a couch, something like that, and you're buying it from someone else, or you're trying to sell it a couple years after you bought it, chances are you're not going to get more than what you paid for, and you're probably going to get less. Electronics, such as computers, phones, etc., because technology is constantly changing, you can see things such as like an iPhone. Over the years, the older models don't have the same value. You're not going to be able to sell an iPhone 7 for the same price as an iPhone 13, right? Or same with computers, right? The original MacBooks, right, are not worth the same as the current MacBooks because the technology in them isn't the same. It's older, or maybe they tend to be less reliable the older they are. Especially technology might break down, might stop working, things like that. And that's the same can be said for equipment in general. Generally speaking, with equipment, the longer you have it or over time, the quality of it, the chance of it breaking tends to increase, which causes its value to decrease. And again, you may be able to come up with some other examples of your own of value or items that lose value over time. So things that when you buy and try to resell, you could say you're not going to get the same value that you got it at. So again, by definition, depreciation is the decrease in value of something over time. You could say it's the decrease in an asset. Again, an asset is just an item that has value. So an asset can depreciate over time, right? You could argue that some things can appreciate and depreciate, right? You think of stocks, right? They lose value over time, or they can gain value. But generally speaking, you're thinking about things that tend to decrease over time. Yes, there are some things that can flip back and forth, but generally speaking, these items decrease. Cars, again, are a common example, and when we're dealing with cars, usually the rate of depreciation is given as a percentage. So just as an example, we can see here a car was bought for $20,000, right? An average price for a basic car, for the base model. You could say that its value depreciated by 10% each year for 3 years. So what does that mean? Well, it means it loses 10% of its value every year. So in year 1, it loses 10% of $20,000, which was the original price, or it loses basically $2,000 in value. That means that after 1 year, the car is now worth $18,000. In year 2, it loses another 10%. However, it's 10% of the current value. So it doesn't lose $2,000 in value, it loses 10% of $18,000, which is $1,800. So the new value is $18,000 minus the $1,800, which gives us a new value after 2 years of $16,200. And then again, the same thing applies for year 3. You're losing 10% of its current value, which was what it was worth after 2 years. And then we find that after 3 years, the car is now worth $14,580, when originally it was worth $20,000. So you're losing almost more than a quarter, or basically you're losing almost more than $5,000 worth of value over 3 years. So you can see how the value is the decrease in value is very steep in just a short amount of time. And again, when you start buying cars or owning cars, you do see that. And so you have to kind of weigh the odds of, do I buy a slightly used vehicle and save quite a bit of money, or do I buy a brand new vehicle and spend a little bit and spend more? So again, it does help you think about these certain situations. Looking at again the depreciation of a vehicle, here we've graphed 3 situations for a $30,000 vehicle. So we're looking at the value of the car over time at 3 different scenarios. If there's a low depreciation, so basically it loses a small amount of value, maybe it's a high-end car, right? Maybe it's something like a BMW, a Jaguar, an Audi, Mercedes, high-value cars like that. That would be in blue. In green, average depreciation. So you think on average what a car might lose. Again, maybe that's something like your mid to high-end models, or car brands. Maybe it's like an Acura or something like, or Infiniti, something like that. And then finally, in yellow, or maybe the slightly orange one, high depreciation. So you're losing a large percentage of value. So maybe that's like your very common brands, like a Ford, or GMC or Dodge or something like that. If you disagree with the models, again, I'm not a car person, I'm just kind of going off the top of my head, but you could think of those reasons as maybe why there's the different scenarios that we're dealing with. Or maybe it's just just 3 different scenarios depending on the economy, how things are going. Right now, cars are in high value, right, due to COVID and things like that. Not as many are being produced, so people tend to be waiting for cars, or there's a high demand for them. So we want to think about, or looking at this graph, what's the same and what's different. So what's the same about our 3 lines, or our 3 different scenarios, and what's different about them? Well, looking at our graph, one thing that's the same should be that they start at $30,000. So in all 3 scenarios, our starting value is going to be the same. $3,000 or $30,000. The initial value of the car is always going to be the same. Again, the only difference might be the brand. What else is the same when looking at the graphs? You could say we're looking at the depreciation for 10 years. So depreciates for 10 years. Maybe it goes further, but for our sake, we're looking from 0 to 10 years for all 3 situations. So depreciates for 10 years could be another similarity. I think a common one that we can see visually that's right off the bat. All 3 decrease in value. So they're all decreasing. There's not a value, or there's not a scenario where the value of the car or vehicle increases, and which again makes sense because we're looking at depreciation. Off the top of my head, those are kind of the 3 things that we can see that are the same. What's different? So again, we can hopefully see right off the bat what's different about the 3 different scenarios, which is they all depreciate at different rates. And the reason we can see this is because at the end, some cars have a higher value, an average value, and a low value. So the values are different after 10 years. That means they have to be depreciating or decreasing at different rates. You could also say after 10 years, values are different. Because again, we can see at the end here, the values for the three different scenarios are all different. So they all depreciate at a different value or at a different rate, and they end at a different value, even though they all start at 30,000. For number 2, we want to interpolate the value of each vehicle after 5 years. Again, interpolate basically just means estimate within the data. So what that means is, because we're looking at 5 years, which is this mark here, I'll actually use a different color so it'll stand out from the lines roughly. Because we're looking at year 5 and it's within our starting value and our ending values, that's considered interpolation. If I said, let's estimate the value of each vehicle after 13 years. 13 is outside the graph that I currently have, so that would be the other type of estimation which we've talked about, which is extrapolation. So to estimate, basically I'm looking at year 5. I'm going to draw a vertical line up from year 5 and see at what vertical height does each line does this red line cross each different scenario. So in the low depreciation, or the blue line, it crosses at between 18,000 and 15,000. So we could argue that maybe that is, say, roughly 16,000. So after 5 years, the first vehicle or the first brand is worth $16,000. Keep it. For the second one, the average depreciation, see, it crosses or it reaches a vertical mark of, say, $12,000 roughly. So after 5 years, the average depreciation vehicle or brand has a value of $12,000. And finally, the last one, high depreciation, so a high decrease in value. Our car's value is about roughly $9,000. So again, different depreciation rates, different values after 5 years. And looking back, it would technically be different at any year because they're decreasing at different rates. Finally, what we're going to be looking at is doing some calculations, and this is similar to what we've done with appreciation. However, we're just going to use a different term, which is depreciation. So we want to calculate the depreciation value of the high depreciation vehicle for the first 8 years. So we want to basically see how much value did it lose after 8 years. Because we're dealing with the high depreciation, we're only going to be looking at the original price we know is $30,000, and we're going to subtract the value at year 8. So if we go back up and look at year 8 for the high depreciation, so again this yellow line or orange, at year 8, right here we could say it's the 0.8 and say roughly $4,000. So at year 8 it's 4,000. So here it's going to be 30,000 minus 4,000. Again, you may have slightly different values at year 8, but roughly in that ballpark. And when we subtract the two, we get 26,000. So basically there's a depreciation value of $26,000 for the first 8 years for the high depreciation vehicle. We can also calculate it as a percentage, right? So again, it may be better to understand in generalities what percent is it losing over 8 years, because in that way maybe you can apply that to many different vehicles, because maybe say it's going to be the same for all these brands, it's going to lose the same percentage. So let's see what percentage this vehicle lost in value. So similar formula to the appreciation, you're going to do the original minus the end, or in this case the value at year 8, because that's what our question's asking, divided by the original price and multiplied by 100. So again, very similar to what we were doing before. So the original price, 30,000, minus the value in year 8, which was the 4,000, divided by the original price, which was 30,000, and all of that is going to be multiplied by 100. So in this case, we have 26,000 divided by 30,000 multiplied by 100 equals and we get 86.6 repeating, or 86.67%. So the percent depreciation is 86.67%. So basically after 8 years, your vehicle is going to be worth, or you're going to lose 86.67% of its original value. For 5, same idea, just a different question looking at a different year and a different scenario. So for the low depreciation, so again, that's the difference here. We're looking at low depreciation. What is the original what percentage of the original value is kept after 10 years? So the percent depreciation is going to be the original price minus the value at year 10. So the original price was $30,000 minus the value at year 10. Let's go back to our graph. And again, this was for the low depreciation, so we're going to go to a different line up here. We're going to say that the value at year 10 is just slightly above 9,000. We can say it's 9,000 just for easier math. So at year 10, or this point is 10, 9,000. Year 10, $9,000 in value. So going back to our formula, we're going to subtract 9,000 divided by, again, the original price, which is 30,000. All of that will be multiplied by 100. Here we have 21,000 over, or divided by 30,000, multiplied by 100. And we get 70%. So the percent depreciation is 70%. So basically what that means is that, therefore, the vehicle loses 70% of its value after 10 years. Or, let me just move all this over. Another way you could say it or therefore the vehicle keeps 30% of its original value after 10 years. So just two different ways you can word it, right? You either lose this depreciation percent, you're losing 70% of its value after 10 years, Or you could think about it keeps 30% of its original value. So again, different ways you can think of it, but the idea is that when we're decreasing in value, it's depreciation, and we can still calculate the depreciation value as well as the percent depreciation, very similar to what we did with the appreciation of assets in a previous lesson.